Good afternoon. Welcome to PAL's Faculty Student Development Program by IBM. Before getting into the session, certain ground rules for the participants. All the participants are stay muted. Please record your attendance in the chat box, which will be posted. Please attend the Slido quiz after the session. And finally, you will get the feedback link. So please submit your feedback also. During the Q&A session, you can ask your questions by using raise your hand, or you can type your question in the chat box. Now, I request Mr. R. Krishnamurthy Rao, PALS champion, to introduce the speaker. RKR. Mohan sir, you can unmute. You have to unmute.
One second. Oh, 1 second. 1 second.
Yeah, fine.
Yeah, Mohan, you have to unmute.
Oh God.
No, Mohan, you are muted. You need to unmute now.
Yeah.
Okay, fine. It's okay now.
No. Can you unmute CNC?
No, 1 second. Oh yeah. If you want to do that, that's
Yeah, you want to please
okay.
unmute
Did
CNC.
you
No, it's
mute?
okay now. It's okay. Now you're unmuted.
Yeah,
That's
done.
why the feedback is
We'll
coming.
take care of
And RKR, now you can talk.
Yeah, you can speak.
it. Yeah, can you hear me?
Yes.
Yes, of course. Yes, we can.
Sorry, I think we are playing with two.
No, I had prepared myself so that yours will be ready, but then.
Yeah.
Okay, now you should be able to talk.
Well, again, you're unmuted.
Okay.
No, it's
Yeah,
fine.
Okay, fine. Right. Yeah.
No, we are not hearing him.
Can you this one?
You want the speaker?
What I do is no.
No,
The camera also.
camera shouldn't affect it, but
Let me Mohan, you unmute yourself.
No,
Yeah,
he's
now we
fine.
can-
There's no problem in that. It's
But now we can hear
is it
you.
Fine.
But now we can hear you, huh?
Ravi
Yeah,
speaking.
fine, sir. Fine, sir. Go ahead, sir.
No, I think I have reduced the
Yeah,
volume.
RKR, now you can
No,
speak
let me
here.
switch off. I think
Wait,
We can hear you,
then
all
it
the
will
three
be no
of you. Now
problem.
we can hear.
no, that's muted. Yeah.
Yeah, Ravi, can you hear me?
Yes,
Yes,
sir.
yes,
Sir.
I
Go
can.
ahead, sir.
Yeah.
Okay. Sorry, there was a
Please go
slight adjustment needed. Now the adjustment
I
is
know.
Yeah. Good afternoon, everyone. Welcome to the lecture series from IBM, in which Dr. Mohan is participating today. Now, let me have the pleasure of introducing Dr. Mohan. Now, as you all know, he's an alumnus of IIT Madras. He did his BTech in 1977, and now he has become a distinguished alumnus. So he has been working in IBM for 38 years and retired from IBM after working there for 35 years from the Almaden Research Center in Silicon Valley of IBM. Right now, he's a distinguished visiting professor at Tsinghua University in China, a member of the inaugural Board of Governors of Digital University Kerala, and an advisor of the Kerala Blockchain Academy and the Tamil Nadu e-governance agency in India. So his research in IBM included the database, blockchain, artificial intelligence, and other areas. And he has worked on a number of IBM and non-IBM products, and also worked on a number of industry standards in this area. He is famous for his invention of the well-known Aries family of database locking and recovery algorithms and the presumed abort distributed commit protocol. I'm sure those who are in the area of computers and database understand the importance of this. And Dr. Mohan has been a fellow at IBM from 1997 to 2020, then with ACM in 2002 and IEEE 2002. And he has also served with IBM India as chief scientist between 2006 and 2009. He has a number of awards and distinctions. Some of them are receiving the ACM Sigmod Edgar F. Codd Innovations Award in 1996, the VLDB 10-year Best Paper Award in 1999, numerous awards from IBM. He was elected to the US and National and Indian National Academies of Engineering in 2009. He was named an IBM Master Inventor in 1997. Of course, as I mentioned, he's a distinguished alumnus of IIT, and he received his PhD from the University of Texas. And to date, he has been an inventor of 50 patents. Since 2017, Dr. Mohan has been an evangelist of permissioned blockchains and the mythbuster of permissionless blockchains. During the first half of 2021, he was the Shaw visiting professor at the National University of Singapore, where he taught a seminar course on distributed data and computing. In late 2019, he became an honorary advisor to TNEGA for its blockchain and other projects. In August 2020, he joined the advisory board of KBA in India. Since 2016, Dr. Mohan has been a distinguished visiting professor of China's prestigious Tsinghua University. In September 2021, he was inducted as a member of the inaugural Board of Governors of the new Indian University, Digital University, Kerala. He has served on the advisory board of IEEE Spectrum and on numerous conference and journal boards. He has also been a consultant to the Microsoft data team. Dr. Mohan is a frequent speaker in North America, Europe, and Asia. He has given talks in 43 countries. He is also highly active on social media, and he has a huge network of followers. More information about Dr. Mohan can be found in his Wikipedia page and in his resume at LinkedIn. And of course, he has got an address which can be shared also separately. So with this introduction, I request Dr. Mohan to take his lecture on artificial intelligence.
Thank you. Can you
I'll
mute and also.
Okay. Thank you so much, RKR, for the wonderful introduction, a lengthy one. Let's see, why is your thing showing up? You are still there. It's showing me your screen. I don't know why. Okay. Yeah. Thanks everyone for joining me on a Friday afternoon instead of going and having fun doing something more interesting, wanting to come and listen to me. So it's a great honor for me to address students across so many universities in one shot. I'm assuming most of the universities are having at least one person listening in on this presentation. So let me now start doing the sharing of my presentation, which is this one. Okay, let's see, let me go to, all right, let me take this window away. So you're all able to see the slides now?
Yes, sir.
Am I audible?
Yes, sir.
Can somebody respond to me, please? Oh, sorry. I had my.
You are audible. Yes, you can carry on.
See, what happened was that my speaker was muted since we didn't want feedback from the other laptop. So sorry, I didn't hear you. Okay, so let me also push this thing to go away. How do I do that? Hide video panel. Okay. No. Hide floating meeting controls. Okay. So I think I'm now set. So as I posted yesterday, and also you were sent the slides of this presentation are available at the link you see, and there is a QR code. And I also did a post in the chat session. So for people who came after I did my post, I think Robin is going to again post the link. He might have already.
Yeah, I'm posting it.
Okay, thank you so much. Appreciate it. So I might not get to say everything I want to say for lack of time, or every time I give the presentation, I tend to say something that I didn't say before, or the other way around, and so on. So in that sense, if you really, why isn't it moving? Okay, let's see. So there is a video version of the presentation I gave in September in Crete. So you can go look at that. And there was also a Q&A with lots of more senior people than I would say the kind of audience I'm having here, which is primarily current college students. So you are more than welcome to look at the slides as well as the video of that. Since you have access to these slides, you can look at all this later on at your leisure. In general, you'll find that in this presentation, I have links to a lot of material that I've gathered from various sources. So I strongly recommend that if you find any particular topic interesting, follow the links. For instance, in this slide, you see at the bottom, this is a clickable link, okay? So please go take a look at these things, not just listen to only what I have to say. For instance, there's a lot of hype about AI. By the way, I just came from an all-day event organized by the Tamil Nadu E-Governance Agency at the Ramada Plaza Hotel. It's still ongoing, where they are talking about AI applications and what Tamil Nadu in particular is doing, as well as research type people coming and giving presentation, like IIT Madras's Professor Ravindran Balraman gave a very nice keynote earlier today. And I posted some pictures in Facebook. You will find a lot more pictures that I'll post later. So things like that are happening right around here for those people who are residents of Chennai that could have gone in person to the event, but even non-locals, they were allowing you to watch the video streaming version of it. So in general, as you can expect, every time some new technology comes, there are any number of people who want to make a quick buck. So they cook up something that doesn't necessarily have a connection to what this new technology is, but they just call it, it's the same as this new technology. So in that sense, all sorts of silly things are being called AI algorithms, applications of AI, and so on. And in fact, under the covers, if you examine it, it might not have anything to do with AI. So there's a lot of the snake oil kind of salesmanship going on. There are some legitimate use cases, but there are also others where they'll say things like, oh, by looking at the person while I'm interviewing, by analyzing the facial expression of the person, I can predict whether this person will be a good employee or not, and things like that. These are all completely bogus kinds of claims that are made, and they'll just call it, oh, it's a deep learning algorithm that's coming up with these recommendations. So you better believe it just because I'm calling it AI, and currently AI is very popular. So anyway, this Arvind Narayanan has got an excellent presentation where you can find a lot more examples of what's going on and why you have to look at everything with not just a grain of salt, a bag of salt, to really, understand what's being done, whether it's got any real meat to it or it's all just focus. Also, you'll hear lots of these e-commerce and social media companies who will say they have so much data that they don't know, how to store it and such. And so because of all that big data that they have, they are able to do all sorts of cool things using machine learning algorithms and such things. But guess what? Not all organizations have that kind of data available. And different organizations have different kinds of customer sets. So I've given you some examples here: B2B, B2C, people to people, government to government, government to people, and so on. They all tend to be, traditional, quote unquote, enterprise kind of organizations, and their business models are also very different. The Googles and the Facebooks and Amazon of the world, especially the first two, and Twitter and so on, they make a lot of money through advertisements. They're not really charging for the recommendations that they make and things like that. Unlike traditional organizations, where if they are money-making organizations as opposed to NGOs, every transaction that they perform has to produce some directly relatable revenue. And so for them, as a result, compute resources and manpower and all that is not, available in plenty. They don't have infinite resources as the Googles and the Facebooks of the world have. And so don't take whatever they say as something that applies to every ordinary organization in India, China, USA, wherever, So it's important for you to understand that if you don't have enough data to train your algorithms, you may not be able to leverage this, what is being talked about as if it's some brand new technology. Actually, a lot of it is age-old technology. AI has had its ups and downs over the decades that it's been around. And so academics are also hyping a lot of things. And even Balraman made that point today, that you better look carefully at your use cases and such to see whether it's even a candidate for using AI algorithms. So AI is not a panacea, and it has its limitations, and we'll talk about some of that. But at the core of all this is still good data. So don't think that, oh, AI is something totally different from database technology or big data and such things, because it's like garbage in, garbage out. If the data that you are using to train your models has lots of things that are problematic about it, the end result will also have lots of problems. So don't think you can take any data from anywhere and train your algorithm and it'll work in a totally different environment than where the original data got generated. And there are also many possible risks with this whole AI business. A lot of it is black box kind of approach. You feed some information, out comes a recommendation or a decision. Is this a cat's picture? It'll say yes or no. If you ask it, why is it not a cat picture? If that was the answer, it won't be able to explain to you, oh, these are the particular places where it looks like a cat, but there are these other features of this input picture that don't look like cat. So explainability is an important thing also. And there is also lots of issues with, if you did the training with, let's say, only white people related information, and then you are trying to use it to, deal with, let's say, black people. We've had some really terrible things like a black person was, an African-American was thought to be a gorilla because that algorithm had not been trained with anybody other than white kind of people. So, and also there's a lot of privacy related implications of AI algorithms, and they can also be used for criminal purposes, military warfare, and so on. And also unemployment could come about if you're not careful with how you deploy this and what kind of environments and what the societal implications are and things like that. And also, deep fakes and such. These algorithms have become so good now. They can even generate human-like videos, but completely artificial. They can even, formulate some music and things like that and pretend to be, some singer in India, let's say, Sudha Raghunathan, but in fact, it was all machine-generated music, and Sudha didn't have anything to do with it. And there are also environmental costs of these huge models, billion parameter kind of models and such, and not everybody has the resources to burn up, as I said a few minutes ago. And also, wasting so much energy for doing some dumb recommendation is not the right way of balancing what you could have done with that energy for much more useful purposes than recommending a movie or, what book you should read and things like that, that don't have the same level of value as some other applications that could benefit from that kind of compute power and so on. There are also lots of bad things that have happened to the point where, as you see in some of these news items, Google and Facebook and such have been faulted for them encouraging fake news and things like that, or when they wanted to introduce fairness in how these algorithms operate and what kind of data they make use of. Some of the people that were brought in, like this person, Timnit, was fired by Google. And there's a lengthy article, you can go read about all these things. Who's making sure the AI machines aren't racist? Just like human beings can be racist, you could also, if you don't take enough steps to guard against it, produce some algorithms which discriminate against, let's say in the Indian context, backward classes, backward tribes, or whatever, somebody from one kind of community versus another kind of community and things like that. And also the input data can be tweaked a bit in order to make the algorithm come to wrong conclusions. Later on, you'll see something about a stop sign can have a few bits in its image modified, and then the algorithm will conclude, oh, it's saying just go slow, 15-mile speed limit, instead of actually a stop sign, which could then result in the self-driving cars or whatever getting involved in an accident, for instance. Also, these days, it's very fashionable for a lot of people to think that AI equals machine learning or deep learning. But in fact, there's a lot more to AI than just that. And so this picture is trying to show you that there is this kind of, what do you call it? Oh, sorry, guys. Let me do this. I should put my phone in the do not disturb mode. There is this core, which is deep learning, then there is neural networks, then there's machine learning, then there is all of artificial intelligence. And we'll see more of all these sorts of things as time goes on. So believe it or not, in the US back in 2019, even the Congress of the US, quote unquote, the parliament, let's say, of the US, in a Defense Authorization Act, actually came up with a definition of AI. And so it talks about this artificial system that performs tasks under varying and unpredictable circumstances with human oversight. And this system can learn from experience and improve performance when exposed to data sets. On and on it goes. So I'll let you read all this at your leisure, but it talks about cognitive tasks, how notion of rationality being depicted by the system, and how you could have just software being the embodiment of this AI algorithm, or it could also involve physical things like a robot, which is being powered with some of these AI algorithms. And there are things like perception and planning and reasoning and learning, communicating and decision making and acting on those decisions, and then observing as a result of acting how that affected the environment, and then having a feedback loop and correcting correcting in case the intended action didn't happen, doing course correction and things like that, right? This is no different from when you are driving. If you don't take the particular exit you are supposed to take, then the Google Maps algorithm says, okay, now that Mohan has missed this exit, let's figure out how to still make him get to wherever he was going. And it'll automatically reroute the path to be taken. So there are things like that. But also there's this mention of how this artificial system is designed to think or act like a human, including cognitive architectures and neural networks, and so on and so on. So there's also this European entity called the High-Level Expert Group on AI. They have their own definition. So what you'll see in the subsequent slides is that there are a number of people who have talked about over the decades what AI means. And by the way, it is decades old. It's nothing that just started happening only in the last 10 years or 15 years. Believe it or not, the phrase artificial intelligence is as old as me, meaning I'm a 66-year-old, and it was coined 1 year after I was born. So I was literally a 1-year-old. In 1956 is when John McCarthy came up with this name, artificial intelligence. And there was a particular event, which I'll talk about later. But here you see systems that think like a human, systems that think rationally, a system that acts like humans, a system that acts rationally. So there's this notion of rationality we all as humans can be very irrational and things like that, but we want to make sure at least these systems will, for the most part, act rationally. So there is all these human-like qualities that we associate with AI. There are many more things that, as I said, that relate to the whole field of AI. So you talk about reasoning, you talk about planning, you talk about learning, communication, and so on, integrating it with other things, multi-agent systems. You might have a human as well as the system working together. So human-machine interactions are also things that you need to think about, and also about the ethics. Is it okay to take pictures of people and post them everywhere? Is it okay to even keep track of where all Mohan has visited during his time in Chennai? There are privacy considerations, for instance. What are the things that can be made use of? Is your health information to be kept private, or it can be willy-nilly shared by people? We do all this kind of gossiping in the real world. We have to worry about such things also in this AI kind of world. So there's also this philosophy of AI and things like that. So there are people across the spectrum in the community, not just engineers and scientists, but also sociologists and various people that are journalists and even gurus and so on, kind of people who all are part of the picture. Just like in normal society, they all get involved. Even in this AI related applications and such, you need to think about those sorts of things. There's even more stuff here that I don't have the time to go. So in a very broad-based way, what is AI and where to use it? AI is, code plus possibly some special purpose hardware. This could be traditional computer that just runs at AI code, or it could be something like GPU or tensor processor that, for instance, Google came up with, which are specialized hardware that are good at doing what constitutes the fundamental kinds of computations that happen in an AI kind of application, as opposed to other kinds of applications, for instance. There are people who do special purpose hardware for even database processing, right? So there are things like that. So where will we have AI? Wherever there is software to gain some benefits. So it's not like it has to be applied only in some very restrictive domains. Even inside a database system, some of the AI kinds of algorithms can be used to make the job of managing the innards of the DBMS, like indexes and when to do backups and when to reorganize the indexes and such, or the tables in order to garbage collect the free space and such things. Those kinds of algorithms could also be made automated ones by employing AI-ish algorithms rather than database administrators and systems administrators as humans having to struggle through all sorts of decisions like that. So the US Defense Advanced Research Project Agency, DARPA, which most of you should have heard about because it's entity like this that caused the internet to come about. So originally there was ARPANET that was funded by this agency that then evolved to become what you and I know now as the internet. So they have a view on AI where they talk about the different periods of AI, and they have a way of measuring in each of those periods how well these AI systems have done with respect to things like perception, learning, abstraction, and reasoning. And for each of those attributes or properties, if you like, they have a way of measuring how sophisticated it is. So this notional intelligence scale is minimal versus adequate versus nuanced versus advanced. So this is the kind of picture you will see. And AI is a programmed ability to process information. What that information is all about will depend on the use case and such. Exactly what you do with that processing, what is the intent behind the information processing will also be a function of what that use case is. So, so they characterize the whole space as having involved 3 waves of AI. The first wave was one where handcrafted knowledge was used to describe a certain domain, how to tell whether some fruit that's handed to you is an apple or not. What does it mean for something to be an apple, for instance? There are rules that are codified that describe what a typical apple is like, color and size and where it's grown and on and on and on. The second wave is what is currently in progress, and that's the one where it makes use of more statistical learning rather than handcrafted knowledge. And this is where things like deep learning and neural networks and all that have become popular, but it has its limitation. And so the third wave will be the one where a lot of the problems of the second wave will get taken care of. And that's still very much an evolving set of ideas. And there's a lot more work to be done there. So the European Union's Joint Research Center on AI characterized the evolution of AI as constituting three periods. The first period from the 1950s to 70s, the second one from 70s to 90s, and the third one that is from 1990s to 2020s. Interestingly enough, the initial periods were ones where academia was more into working on AI than in the latest wave, where industry as well as academia had significant roles to play. It was not just researchers, but also actually product people and non-research kind of establishments. And also in terms of the funding, there were differences. And also in terms of the compute resources available, there had been dramatic increase in the number of transistors per chip and things like that. And also there wasn't as much regulation regarding where what can be done and where certain things cannot be done and things like that. The ethics of AI and so on, privacy considerations were not so much focused on in the 50s to 90s kind of area, but of late, that's also become an important thing to worry about. But none of these three periods that these guys have talked about is capable of doing general AI. It's all restricted kind of application areas and restricted functionality was what was possible. And as you can see in the graph on the left, there have been times when AI was hyped a lot. There were all sorts of expectations that the people had based on what the people working in the field said. The general population thought AI will do lots of things, but then there was disappointment because the people who hyped the topic didn't deliver on the promises that they made or the extrapolations that they made. And so there was a reduction in the focus and all that. And so then they call it the AI winter when there is a dip in the popularity. And then again, after a period of time, it started becoming hot. And then again, there was a disappointment because they didn't deliver on the goods. Now there is like exponential rate of increase in the popularity, and it's still possible. Some of the things that people think are going to happen might not actually happen. It's interesting to observe, in one way, how this field has matured and has become popular by looking at what the ACM, the Association for Computing Machinery, calls the Turing Award. This is like the Nobel Prize in Computer Science. There is no Nobel Prize in Computer Science, but informally, this ACM Turing Award is thought of the Nobel Prize in Computer Science. And if you look at the award, I think the first time it was given was probably in '64 or something like that. The first time it was given for AI was in '69, Marvin Minsky. And then the most recent AI award was in 2018 for these three people who did the work on deep learning. And it's also interesting to observe who else has got it and what institutions they belong to, where they did the bulk of their work that resulted in this award being given to them. And did anyone notice there's one Indian name here? And that's Raj Reddy. Guess what? He not only got the Turing Award for AI, but he has the distinction of being the only Indian ever to have received the Turing Award in all these decades of the award being given. And guess what? He got his bachelor's degree across the street from where I'm sitting at the Gindi Engineering College. And he got it at a time when IIT Madras had not even been established, or at least he joined when IIT Madras had not even started. And if I remember right, he got his bachelor's degree when I was again a 1-year-old or something like that. So please pay attention not only to algorithms, this, that, but also the people behind it. And by the way, Raj is a good friend and he's still very active. He's 80 plus or something now. And he's still associated with Carnegie Mellon University. It's important for you also as youngsters to get inspired by looking at people like Raj and others that are listed here. And so just don't learn technical stuff, but also go behind the technical stuff about the people that did it, what motivated them to do, what they did and what struggles they went through and things like that, because anyone can aspire to reach any mega goals. So it's crucial that you don't think, oh, only if you're born here or born there, or you went to this college or that college, you can aspire for bigger and better things in life. Doesn't matter. You don't have to be an IITian to become a big deal person. And I'm not talking about just money making. I'm talking about even awards and such, and technical recognition. All my life, I never took up management, by the way. So it's important to also look at the various events that are associated with AI. As I said, there was this event okay, I don't have that information here. I'm a bit surprised it's not here. It's probably in another slide. Oh yeah, it's here. 1956, the Dartmouth Summer Workshop. That's where there was this widespread usage of the phrase artificial intelligence. And the people who participated in that workshop in the US East Coast subsequently became like major personalities in the AI area. And you might actually compare some of the names here with the Turing Award names, and you'll see some interesting things. So in the first decade of AI, heuristic search for problem solving, syntactic computational linguistics, checker playing programs and such were the things that were focused on. And this was followed by, in the 65 to 1990 space, on knowledge-based systems, where the concept of expert systems was the way in which the knowledge that came from humans got codified in the systems for the systems to be able to make some decisions. They even worked on a system that will codify not just information, but also principles and so on. What is a tree? What is a plant? What is a fruit versus a vegetable? Things like that. So there's this common sense knowledge representation called psych was worked on by people at the Stanford Research Institute and later on carried out in Austin, Texas. There was also this notion of rule-based and statistics-based reasoning and such. So there's a computer history museum in my part of Silicon Valley where they made a video on AI, and one of the people that got the Turing Award for AI, and this is gentleman, Ed Feigenbaum, who got it with Raj Reddy, he gave a presentation at Stanford that I attended where he talked about, what things relating to AI got captured well in that movie made by the computer history. Oh man.
Who's this?
Oh, okay.
Basically.
Is the presentation here though?
Oh, no, it's not.
Oh man. Okay. This power went away. So you should say something here. Just
There's a
I will project it.
interruption. The power went away. There's some power problem with this
No problem, no
laptop. Just
problem.
give a couple of minutes to set it.
I didn't realize this something.
Sir, Dr. Mohan, I will share it, no problem.
I think the PowerPoint, this new slide is here.
You have it here?
Yeah, I have it.
Okay. See, this red thing had gone away. So annoying. And then this guy went into this. So
I think it's just started.
You can see I have projected.
no, somebody else. You should increase the volume there
Increase the volume. Increase the
because I think Robin is saying something.
Robin, can you present the slide?
Yes, that's what I told.
Yeah,
I have already projected.
He has already put it up.
No, but you should go into the. Okay, maybe
Yeah,
this
I'm
guy
going.
came
I'm
back.
going. Just stop me.
Sorry, guys, this is ridiculous.
Okay, this one.
Okay, okay. Should I just do it from here? Okay.
But I think he will operate for you.
Oh, I see.
I think.
I'll get this up.
Okay, let me. Maybe this is.
My name is Chandrasekharan. Jason is my laptop.
This is annoying. God. Okay. You should.
Power has come.
Okay, are you guys able to hear me?
Yes, sir.
Sorry.
Shall
Okay,
I stop share?
yeah, I can.
You are sharing.
Oh, wait. Oh, this is what he's sharing. Okay, I have to still share, I guess. Okay. Yeah.
Yes, fine. You need
Okay.
inside.
Okay. So, yeah. The first wave of AI is something, as I said before, where perception was at the minimal level. There was zero learning, there was zero abstraction, but reasoning was pretty good. It was, I forget now what this level is called. It's nuanced, okay? What you see as the third stage, if you like. The first stage is called simple, I think. Let me go back to that slide. It's minimal, adequate, nuanced, and then advanced, okay? Those are the four possibilities for the notional intelligence scale, okay? So, it was pretty useful in the planning area, command post of the future, expert system, cybersecurity, and things like that, okay? But there was no learning capability or poor handling of uncertainty. And there are some significant conferences that have been around for quite a long time. The most important one, worldwide one, as opposed to just a US-based one, is the International Joint Conference on AI. And it was held in 1969 for the first time. And for instance, in 2008 or something like that, it was held in Hyderabad. That was the first time, as far as I remember, it was held in Hyderabad at the brand new, at that point, International Conference Center. And I said, let me look at what the topics were that were the session topics at that conference. So here you see the list of things. And they're all over the place: physiological modeling, self-organizing systems, psychological modeling, pattern recognition, pictorial pattern recognition, and so on and so on. Okay. And also, there are these different events that have happened over the decades, even preceding the notion of, or the terminology of AI being proposed that have relationships to AI, which is things like, the golden age of science fiction, which spanned from 38 to 46. And then there was this Turing test. Can machines think? Can you tell if you're interacting with somebody on the other side, whether that somebody is a human being or a computer program, just by interacting with it, where you don't get to hear or whatever, you see something that's being typed, but will you be able to interact with this other entity in a way for you to come to a definitive conclusion that it's a machine as opposed to a human being? Things like that. So that's a famous one. And then, of course, there were things like the Deep Blue machine that my previous employer, IBM, came up with, which defeated the best human in chess. That was Garry Kasparov. And that happened in around 1997. And in between, Feigenbaum at Stanford did this work on expert systems. And there were even systems that were developed at Stanford Research Institute called Mycin, which was supposed to help a physician help in diagnosing diseases and all that by assisting the physician to let that person know more about what the symptoms are for different diseases and things like that, instead of that person having to remember everything from what they learned in medical school. Also, as the world evolves and new things come up, COVID, whatever, these sorts of systems can be made to learn information about new things and such. And Japan also did something called the 5th generation computer project, which made the Western world think that they were going to take over the whole world with respect to AI-ish kind of technologies being developed, where they'll get superiority over the West. Guess what? Similar things are happening right now, where China thinks it's now its turn to do so much dramatic stuff in AI that they will leapfrog the Western countries, in particular USA, and take away the leadership position in terms of not just money making, but also even research and such. So there's a lot more here about how you gather knowledge, what kinds of knowledge are there, what are the sources of knowledge. There is a sort of algorithmic way of doing things, where you come up with laws like E equals MC square, where formulas can be developed and can be applied to solve certain problems. But there are other areas where, like game playing, where it's more a trial and error kind of method. You do search, which compensates for lack of knowledge. But things like F equals MA and E equals MC squared, those things are hard to come up with by just doing exhaustive search and things like that. That's where, brainiacs like, the people who came up with these sorts of things like Einstein and so on, whatever it is in their brains that made them come up with something and test it and see whether what they've come up with is actually the physics dictated the equation like E equals MC square, for instance, or force equals mass time acceleration and so on. And there is codification of knowledge, experiences that humans have that they might pass on from one person to another person. Could those things be translated and put into a form where systems can then now have that knowledge embedded in them, and as time goes on, they can also learn. How do you do all this? That's where it's a lot more than just coming up with a deep learning model, because here you need to have more method to the madness than just doing statistics-based way of taking labeled data, training the system, and based on that labeling that relates to a particular domain, only be able to handle such things. But if there are some variations between what you encounter in the real world versus what the training data characterized, then you might not be able to deal with these variations that are coming out. This is like, in some ways, what's happening with COVID now, right? You had all these variants and tests were developed, but suddenly now you have this new variant, and your existing things might not deal with it. And so how do you now make the system itself learn about these new variants and adapt the solutions? And that's like vaccination and such things. There have been major breakthroughs even in the good old days, long before the latest hype about AI, where apart from Deep Blue, there were proof checkers. There was even self-driving cars, but not in city streets, but across the highways in America. So this was many decades ago that the DARPA guys funded this project, and Carnegie Mellon had a project called No Hands across America. But it's much easier to do these sorts of things in the highways where you don't have pedestrians and horses and bullock carts and things like that, than when you are in city streets these days with even bicyclists and all sorts of people who do random stuff that are much harder to anticipate and deal with when they do some dumb things, or pedestrians crossing the street and things like that. And then there were speech recognition systems. Even when I was in IIT from 1972 to 77, I was well aware of what Carnegie Mellon people were doing, in particular Raj Reddy, in the speech understanding area, where they had some very specialized ways of looking at things, looking at the syntax and semantics of the language, as well as the phonetics, as well as measuring the frequencies and so on, which is a lot more than what the current fad of the neural net-based way of doing things involves. So when there are ambiguities, whether somebody is referring to Jaguar the animal or Jaguar the car, by looking at the rest of the sentence and looking at the grammar and all that, you'll be able to more easily distinguish between in what context Jaguar the car could be referenced versus Jaguar the animal might be referred to, and so on. So there's a lot more to this than just mechanical way of doing it, if you like, as has become the current popular thing. So as I said before, in the AI 2.0 version, some of these slides, by the way, were from Raj Reddy. I put the name on some of the earlier slides. But this one, I myself was in Shanghai in November 2017 at an event where I spoke about blockchain, but the major attendees in the plenary session, which included Raj Reddy, were the Chinese, not only the academicians, the National Academy of Engineering of China, there were also people who were part of the decision-making body of the Communist Party of China and such well-known figures. And China had just had their once in 5 years kind of mega conference at the Communist Party level, where they make mega decisions about what will happen in the following 5 years and so on. So that's when the announcements were made about the fact that China has this ambitious goal to leapfrog the West. And they also felt that the kind of information that the Chinese companies had gathered, they are the equivalents, if you like, that started out in China, and now they are expanding outside of China also, to the Western equivalents of things like Facebook and Twitter and Google and such, right? And also Amazon, for instance. So these companies have gathered so much information about the billion+ people in China that they feel are akin to the people in big countries like India with its own billion+ people, as well as whatever the number is of the people in Africa and South America and so on. Because they feel that the Western companies have information more about the richer folks, if you like, with certain lifestyle and a certain way of living and so on, that they've collected. Whereas what the Chinese companies have collected about the not so rich people of China will be more applicable to others in these other geographies that I mentioned. So for such reasons also, they feel that they have a leg up on the Western countries. And so they are also focusing on things like facial recognition and special purpose chips. And also they are not as concerned about privacy and such things that the Western countries get distracted by or think are important things to worry about in a societal context. And so, censorship and all that and such are also looked upon differently by these different kinds of countries with their different political thinking and so on. So one of the interesting points that Raj Reddy made at this event was that when he was working on this kind of stuff decades before, he thought that certain problems that he had encountered will not get solved in his lifetime. But he then said, guess what? Actually, a lot of those problems have been solved. And so he was trying to rationalize what was it that changed, that enabled these problems to be solved. And that's where he said it had to do with the vast amounts of data becoming available, and also the incredible amount of improvements in the hardware space and algorithmic improvements in the AI algorithms. These three things he had not anticipated will happen in such a rapid fashion and in a more widespread way across the globe that he got surprised. And so in any case, there is this concept of AI for a certain purpose versus AI for AI in a general way, across different domains and so on. A single algorithm that you develop can by itself adapt itself to different domains and such, and learn as it goes along and things like that. It's somewhat like when a child is growing up, how does it learn about the world? When a baby is born and you look at how the baby grows to, let's say, a 10-year-old, not everything is being fed, spoon-fed by the parents or others involved in that baby's growth. There is also something that's going on in the brain of the baby, that it's using the different inputs, touch and visual and hearing and all this kind of stuff, the different senses. It's able to learn concepts and such. So it's all of those sorts of things that are important. There are, of course, new sources of data that have come about with multimedia and social media and various things. So here is a characterization of some of that. It's not just formal learning, but also what you learn through Facebook groups and such things, or what used to be the Usenet groups in the good old days for the older people amongst us. And also things like crowdsourcing, Mechanical Turk and such things. There are so many such things, right? And also making use of things like sensors and such, QR codes and various things of that nature that are all fueling not only the increase in the amount of data that's available, but also that can be used effectively to automate certain things rather than humans having to process all this data, which would involve a lot more expense and a lot more knowledge on the part of the humans to be able to do this. And some of it is really, really boring stuff that people might not get excited about. And so if you look at, the IJCAI conference, the International Joint Conference on AI, you can go now in your leisure, compare the session in that very first conference, which I think was in 1969, versus the 2019 one. There are some topics that are more or less the same as the very first conference, but there are also others that are very different, and also there are further specializations and things like that. And this conference has become a huge event in terms of tens of thousands of people attending it and things like that. From the time when maybe the original conference had 50 or 60 people as attendees, and maybe a smaller number of them were the presenters and such things. So it's interesting to see how the focus has changed in so many ways. So the second way of AI is the one where I said, if you look at this notional intelligence scale, perception improved, learning improved also quite a bit from 0 to the third stage. Abstraction went to just the first stage. But guess what? In reasoning, it went backwards. Reasoning fell back because there was all that handcrafted knowledge in the first wave. You didn't have that. You don't have it in the second wave way of doing things. If you choose to only go with this deep learning way of figuring out certain things. And so AI systems have nuanced classification and prediction capabilities in the statistical way of doing things, but they don't have any contextual capability or minimum reasoning ability. And some of the example applications of the statistical learning method are things like Apple Siri, text analysis that Google does, or image recognition, and also this AlphaGo kind of gameplay. And what caused this major move to happen, as I said a few minutes ago, from what Raj Reddy said, are the sorts of things that are depicted in this slide. Better machine learning algorithms, vast amounts of data becoming available, and also the improvements in the hardware, not just regular CPUs, where due to Moore's law, power improved dramatically every year and a half, doubling of the number of transistors and so on. But you also had more efficient ways of doing certain things through things like GPUs, rather than relying on traditional CPUs. And then there are other things like tensor processing unit and such. Also, there is a characterization of the different domains in this bottom right corner. And that was measured by looking at the number of patents issued between 2004 to 2013 as to what areas they were granted in. So you see various things like personal assistance, news analysis, shopping, financial services, cybersecurity. You heard yesterday's speaker talk about cybersecurity, for instance, and how some of the machine learning kind of ideas can be used. But you also have natural language processing. That's a big, big area. Not too many people talk about it and what's involved there in terms of dealing with different natural languages, Chinese versus Hindi versus Tamil versus Telugu versus Mandarin and this and that, right? French. Some of it, if you take into account the syntax and semantics of the specific language rather than just doing pattern matching, you might do better, as I said, how it was done with speech understanding in the early years. Another report you might want to look at is the Stanford AI Index report. Every year, the Stanford Institute on AI puts out this report, and it goes into various important conclusions that they arrived at by crunching a lot of data. And they talk about how AI investments in drug design and discovery have increased significantly. And you see the numbers here between 2020 and 2019, for instance, and how the industry shift has happened, how more and more of the PhDs coming out of these AI-ish kind of topics are choosing to go into industry rather than going into industrial research labs like the one I went to, or academic institutions like Stanford and IIT and such, right? There's also this notion of how systems are able to generate human-like audio, text, and images and so on, where it's hard for someone who looks at something to tell whether what the person is looking at was generated by a human or by an AI algorithm. And this is where you have all this fake news and fake videos and all that proliferating across the globe now, where they even make me give a talk on something that I have no knowledge about, I don't know, Carnatic music or whatever, as if I'm actually talking, but it's all mechanically generated. And also there's this diversity challenge in terms of, what sort of people are the ones, for instance, in the case of the US, 45% of the new US resident AI PhD graduates were white. By comparison, only 2.4% were African Americans and 3.2% were Hispanic. So there's all this concern that if only certain kinds of people are working on some topic, then they'll tend to focus more on their own kind of people's problems than what the problems are for the rest of society. So this is where fairness and all that has become an extremely important thing. And as I said before, China wants to take over the world in terms of work in AI, right? So that's showing up already in terms of journal citations and so on. Chinese papers are getting more journal citations than US papers, for instance. And it's different in the case of conference papers, and so on and so on. So I'll let you look through some of this more, but the bottom line one, the 9th one, says AI has gained the attention of US Congress. And I already showed you at the very beginning, a law of US Congress even defining what AI is and things like that. So the notion of artificial neural networks came about in the 1950s. So essentially, if you look at this diagram, on the left, you have the input, which is a cat picture. And then on the outside, it says it's actually a cat. And what's happening in the different levels of this neural network are things like it's analyzing the picture to see what portions of the picture are dark versus what are light. It's then identifying edges, then figuring out enclosed spaces with multiple edges, which might constitute the mouth of whatever the thing is, or the eye, or the ear, and so on. But initially, it just comes up with this, enclosed space. And then it tries to figure out, is this enclosed space the mouth, or is it the ear, and so on. And then it says, by looking at the combination of features, oh, this looks like a cat, and it's not a dog, right? So this is how you might even tell somebody who doesn't know anything about cats or dogs how to look at something and figure out whether it's cat-like. And so this is quite an interesting exercise, right, that we as humans go through. And this one is doing it in a more statistical based way. And so there is more information here about how this is all done. So I won't get into the details here since I'm running out of time. But the other approach, the symbolic lens as opposed to the neural lens, is the one where, as I hinted at the beginning, for an apple, you talk about its origin, structure, kind, and so on. The body, the size, what are the different colored apples that exist in the world, and things like that. So this is really, in a more systematic way, codifying the way your textbooks would have talked about, different kinds of trees and different kinds of fruits and so on. So this is the way in which things used to be done, the symbolic lens, in the first wave of AI, whereas the current popular wave is the neural lens approach. And so it turns out, because of all these developments I mentioned before in the data space, algorithms, and compute, starting from about 2015, the error rate of the system went below the human error rate. So these systems became better than humans. And so there is this evolution of AI that goes from narrow AI, which is what some of those things are, where the ImageNet classification error by the system became better than the humans one. But that works only when you have large amounts of training data. But then you want to be able to do in a multi-task, multi-domain space with less amount of data. And that's what broad AI is all about. And the broad AI is the space which is essential for enterprises, where you need to be able to reason more and learn more. Not just say, oh, you showed me a picture and you asked me whether this was a dog, and I'm telling you it's not a dog, but I can't tell you why I'm concluding it's not a dog. Or you are giving me some symptoms and certain measurements that were made of a patient, and you want me to tell you whether this patient is susceptible to cancer or already has cancer. And whatever I give as the answer, I won't be able to rationalize to you what are the features that were input that led me to this conclusion versus the other conclusion. If you deny somebody an insurance claim, they will sue you if you are not able to justify on what basis you denied them the insurance claim. You can't just say, hey, I fed all the information about you to this black box, and that came back with this answer. That's all I'm able to tell you as the reason for my decision. So there are many of these so-called explainability kinds of things that you need to be able to deal with. And of course, in the even great, far into the future space, what we want to be able to do is the general notion of AI, which is across domains, where you are able to seamlessly go from one domain to another and learn and reason. And this actually involves a combination of the neural approach as well as the symbolic approach. That is, it's combining these two ways of doing things, neural and the symbolic lens. And that's going to be a more futuristic thing. Artificial general intelligence, that's what this AGI acronym means. So in the specialized space, things like language translation, speech transcription, and language processing and visual recognition have gone well. And there are, usages like the ones that you see here, where in the field in Iraq, for instance, the US soldiers were carrying some things in their hands, which they could speak into in English. And the output of that thing will be in Arabic for the guy on the street to understand them. And then the guy responds in Arabic, it'll do real-time translation to English and such. And then you have all these things like, following humans in a game and things like that, right? Whether it's American football or baseball and things like that, or identifying certain important words in a text and so on. But there are problems with all these approaches. Like, for instance, tweaking a few bits in the picture of a panda in order to intentionally screw up the algorithm can result in the algorithm concluding it's a given, completely different kind of animal. Okay, and also people were able to troll. The internet trolls were able to cause this AI bot called Tay to act offensively, where it thought that Hitler did nothing wrong, things like that. And this picture of a kid holding a toothbrush was thought of by the algorithm as a young boy holding a baseball bat. So there are many things like that that can become a problem. There's more stuff here that I won't be able to talk about. Gartner report on who is the leader and so on, the famous four-quadrant chart, where they characterize different players like IBM and Google and Microsoft and such, where they are with the completeness of their vision versus the ability to execute. There are many popular open source AI libraries and frameworks. You can go look at these things. There are even pre-trained models that are available for doing things like computer vision, NLP, natural language processing, reinforcement learning, and things like that, audio and speech. So you can freely use these things. With all this also, there is question of where is the data that's available. Even in this morning's conference, this question was asked about Ravindra and Balraman. There are various governments that have published in the open.gov kind of space, government information freely to be usable by anyone. But there are other spaces like Facebook and Twitter and so on. They don't easily give you their vast amounts of data that they've collected. Sometimes they'll let you pay for it and get some small part of it, but for the most part, they want to squander all that for themselves and benefit from it to make more advertising revenue and things like that. There are various national strategies that have come about in the case of many countries. So over the last few years, every country almost on earth wants to figure out what they want to do in the AI space, because they all think that this will give them a leg up in terms of competitiveness and new jobs and money making and products that they can produce that are more popular and more usable and various attributes. For such reasons, both in the developed countries as well as in the developing countries, there have been concerted efforts. And so you will see that, as I mentioned a few minutes ago, China as of July of 2017, the China State Council released its next generation AI development plan, and they are very systematic about it. This is going far beyond the kind of 5-year plans we used to do in India. These guys are very serious. Once they get into a certain space, they will go like clockwork, and money is no object, and so on and so on. And also government rules and this and that. In India, we have democracy has its own negative things compared to countries like China or even some of the kingdoms and so on in the Middle East and things like that. And so they have many specific goals they have set up. So for instance, by 2030, they want to become the world AI leader. And of course, their primary target is really US, because that's currently the #1 country in various technological space and high tech especially. But I'll let you read through these things. There are translated versions of the Chinese documents. This New America guys have put out the translation of the original document and their own analysis of what they think about can China actually achieve these things or not, and what the rest of the world, in particular the Western countries, should do to, prevent China from taking over, the economic might and this and that, and dislodge especially the US from this kind of very superior position, not just from the nuclear kind of things, but also from an economic standpoint and innovation standpoint, and so on and so on, leadership in technical space and things like that. The European Union, while some of the countries have done their own thing, the Union as a collective organization also has come up with stuff. So they are establishing networks of European AI research centers, excellence centers. They are also worrying about testing facilities, and in particular for the application areas like mobility, healthcare, manufacturing, agro, food, and security. They're also talking about ethics by design and security by design, instead of these things being thought of as an afterthought after you've developed something. From the beginning itself, worry about these things so that what you do winds up not just helping with certain applications or reducing cost and reducing defects and things like that, but also is ethical and is secure and not easily hacked into and things like that. And they are trying to do more synergistic and cooperative work across the EU. And so they come up with this 3 pillars of European AI strategy. In particular, they launched this entity called AI Watch, and they produced tremendous number of interesting reports. For instance, this 2019 activity report. And I've got many references here to some of the things that they have put out, AI history timeline. They're keeping track in a easily digestible fashion. What are all the important things that are happening, that happened in the past as well as they happen in the future? They are documenting it and making it easy for people to do all this. Meanwhile, India also came out with the national strategy for AI, and they call it AI for all. Some of this was referred to even in this morning's event. And so there are these documents. India is also very proud of talking about responsible AI, not just doing things because it's interesting or whatever, but also being societally responsible and things like that, worrying about bias and privacy. It's interesting to observe the different national plans differ also with respect to the sectoral focus. It all depends on what the economy is all about and what matters, and availability of natural resources and this and that. India obviously is like 80% of the people are more into agriculture, or at least live in rural areas. That's not the case with many other countries, right? So these sorts of things also have a bearing on what gets focused on. And there are these other documents that have been produced that will also be interesting for you to look at. Itihasa, one of the IIT Madras alumni, Chris Gopalakrishnan, has funded this. They put out this report on the landscape of AI and machine learning research in India. They also put out one on brain research. But the Tamil Nadu government in particular, and they were very happy to refer to this in this morning's event, took this leadership role in putting out this report on safe and ethical AI policy back in 2020. And also NASSCOM has put out this report saying, more than actually developing the model, generating and curating the data that feeds into such models itself can be $1 billion business area. So preparing the data and labeling the data and so on, correcting mismatches and things like that, or inconsistencies across different sources, is very time consuming, painful and such. And there the mass of India could play a significant role. This is not too different from speech transcription that used to be done by entities in various parts of India as well as in the Caribbean and so on. They listen to the Western doctors' spoken words, and they will then write it down and worry about making mistakes and things like that. But now data processing in this context, data preparation really, and cleaning the data and so on for being made use of by AI algorithms has become an important topic. There are some of the things I already referred to this, Balram and Ravindran. the IIT Madras Institute, which is doing very good work jointly with Robert Bosch, the German company, and such. Our own classmates, Chandrasekharan's and my classmate P. Anandan, until recently was the head of the Wadhwani Institute for AI, which was started in Mumbai by these two brothers, one who's an alumnus of IIT Madras and the other one IIT Bombay. They are focusing on AI for social good, which was also the topic that was discussed this morning. And so there is also this very good source of information called India AI. So the central government also has been extremely focused on this. There was this fantastic conference in October last year called Responsible AI for Social Empowerment, RAISE. The Prime Minister of India inaugurated that, and I listened in on a lot of the presentations there. Some of that stuff will still be available if you go look for it. Indian government also announced access to geospatial data that the government had collected over a long period of time. And some of this is all supposed to enable applications to be developed by for-profit as well as non-profit entities, as well as for scientists and so on to train their algorithms on and things like that. And there are also multinational companies that have labs in India that are focusing on AI. So the former head of the IBM India Research Lab, Manish, he's running now the Google's AI Research Center in Bangalore. And Microsoft Research in Bangalore is also working on this kind of thing. So, of course, the Indian companies are also focusing heavily on this topic, but they are not necessarily research-oriented companies like Infosys and TCS and so on. IDC has got some prediction. I'll skip this. Singapore, for instance, has its own national strategy, being what it is, a city-state, and also given the fact that their harbor is world-class and it's at the middle of all this east-west trade and so on. Their use cases are focusing on intelligent freight planning, seamless and efficient municipal services, chronic disease prediction and management, personalized education through adaptive learning and assessment, and also border clearance and so on. So this is what I mean by saying the different countries have taken different approaches to how much they leverage universities, depending on how knowledgeable their population is, and so on and so on. And so the US government is also very much involved as a government entity, as well as jointly with the private sector and other organizations like universities and such. I don't have the time to go through all this. DARPA has started some initiative called AI Next with more than $2 billion funding. They've also have developed these so-called R&D strategic plan, and they are looking at various aspects of how to ensure safety and security of AI systems, better understand national AI R&D workforce needs, how to develop skills in this new technology. There's a great deal of demand, but there aren't enough people to satisfy the demand, and develop shared public data sets and environments for AI training and testing, social implications of AI, and so on. There is also this funded project, the National Science Foundation, which is led by, believe it or not, Tamil guy now. It used to be some years ago a classmate of ours. That was the NSF director, Subra Suresh, who is now the president of Nanyang Technological University in Singapore, whereas now it's Punch, who is the head of NSF, the second Indian, second Tamilian, it so happens, interestingly enough. And so anyway, that NSF has funded new nationwide institutes focusing on different aspects of AI. And for each of these initiatives, there's a primary university, and I've listed some of this. Our own classmate is at University of California in Davis, Prem Devanbu, for instance. And then UT Austin, which is my alma mater, they have this AI Institute for Foundations of Machine Learning. And then there is also this Office of Management and Budget in the US. They have come up with principles of stewardship of AI applications. So there's lots of stuff. And then the Bosch guys had an interesting conference last year where they said, in the context of self-driving cars, and Bosch is big time into industrial manufacturing and so on, they said, we can't test everything for these self-driving cars in the factory itself, because it's very hard to create test cases for very rare events. But if you instrument the cars that are being driven by, that are being used by people out there in a self-driving fashion or partially self-driven, through that instrumentation, they can get a lot more use case information, and there will be more of the actual instances of these rare events happening, because the volume is much higher in the field than when you're doing the testing in the factory. So this combination of data from the real world in conjunction with what is done in the testing space is a better way of checking out what's working, what's not working, what's problematic and such. So they talk about the challenges in developing some of these AI models. And then they say, guess what? Just doing data-driven models is not a good idea. For instance, why should you analyze lots of people actually driving kind of scenarios to figure out in this stretch of the road, the maximum speed limit allowed, what the speed limit is, 25 miles per hour. Whereas in that part of that same street, it's 35 miles per hour. Such reference data should be input explicitly. And also certain things that are like E equals MC square kind of thing, which are physics-based models, they should also be incorporated into this rather than learning such pieces of information the hard way, because some of this cannot be learned, or you still won't be able to rationalize why certain things are happening in a certain way and so on. So there is a big difference between physics-based models versus data-driven models. And so they said there are situations where you want to combine these two things in interesting ways, and there's these different ways of combining them. And so they actually gave some examples of these so-called hybrid models, where for certain things like when you are very close to a car, visual analysis is better than trying to do it through things like, what is it called? Radar way of doing detection. Yeah. So I skip through some of these things. So the third wave, as I said before, is going to be contextual adaptation, and that will improve both the abstraction and the reasoning, whereas perception and learning will be the same as the second wave. There's a lot more things to talk about how the R&D investments have happened over the years. In order for you to go from AI for certain area to general AI, or to begin with even broad AI, there's a lot more stuff you need to worry about in the space of explainability, security, ethics, and also learning from small data. As I said, in the enterprise kind of context, anything other than e-commerce and the social media space, you won't have enough information available, data available for you to train. So you need to come up with different ways of doing that. And also even the physics of AI, where special ways of doing the hardware to help with getting more power, if you like, to solve the huge demand on the requirements that are being placed. For instance, every 3.5 months, the AI training jobs, compute requirements are doubling. This is like much, much higher than the Moore's law, which says every 18 months, the power available is doubling if you go by number of transistors per chip. So there are also other things that are being done. In addition to digital cores, even analog cores are being deployed. And even in the case of the digital core, instead of doing full precision arithmetic, reduced precision is good enough. And they even talk about, instead of double precision, you go not just to single precision, but even 8 bits and 4 bits and things like that. So there's more material on all this in the subsequent slides. And also they are developing some new materials in the non-volatile memory space. There is this idea of trying to move some of the computation to the memory itself, because in the non-volatile memory, there is some extra circuitry that's there to, in a physical way, change the memory in order to do a write. And some of the circuitry that's there could also be used to do some simple-minded computation. So instead of dragging the data to the CPU, you are able to do certain kinds of computations that are important in the machine learning space in the place where the data is, thereby getting more parallelism and so on. So AI for the enterprise is going to now require that you advance the core AI and also make it more trustable by dealing with this robustness issue, transparency. You need to be able to explain to somebody what are the factors you take into account in order to say somebody is creditworthy or not. You cannot just say, believe me, I'm doing the right thing, because this is what leads to corruption and so on, right? So also scaling of AI. In order for these AI algorithms to work well, even inside the algorithms themselves, you want to leverage the functionality of AI to improve its way of doing things. So this chart tells you where we are today and where we want to be in the future, and at different levels across the stack, what are all the things that need to be done in order to reach this higher level of functionality and adaptability and all that we are hoping to have. And AI for AI, how to make even the preparation of the data and all that be made easier by leveraging AI techniques, and also within the database system, as I said at one point, using AI algorithms so that you don't have a hard-coded cost model for query optimization and such things, whereas the system can dynamically learn those things. There's also the speech and debate kind of competition where IBM came out with a system that's far more sophisticated than the Watson system, which beat the two best humans in Jeopardy game. This requires a lot more things than what that system did. And so this is one where the computer is engaged in speech and debate competition with humans, and there is a lot more of natural language processing and human-like descriptive statements having to be produced, because the system is now interactively looking for facts to buttress its arguments and so on, which could be for the proposition or against the proposition of the debate. And there's a very interesting article in Nature magazine that goes into all these things. So IBM, by the way, also put out some of the new debater AI technologies to be available on the cloud. And there's more discussion here about what it means for the system to act like a human and talk like a human and come out with well-formed sentences and things like that, that go far beyond the simple question answering that was done in the case of Watson. And I'll stop here. So we want to go from narrow AI to broad AI to general AI. And we are still far away from even being able to do broad AI, let alone general AI. If you want to keep track of some of the newer things, I keep revising this presentation, so you are more than welcome to look at what's here. I think that's the last slide. Yep. All right. Welcome.
Thank you. TNC sir, shall we go for the slide?
So I'll
You
stop.
can go for the question answers. Thank you. You can go for the question answers.
Okay. I stop sharing, right?
Yeah.
Okay.
Okay. Participants, you can ask any questions by you raising your hands. So I will unmute yourself, or you can type your questions in the chat box. Sir, explain a bit more about debater AI. That is the question.
Raman, you can initiate the question answers.
Yeah, sir. Dr. Mohan, we have two questions. Explain a bit more about debater AI.
Oh. Okay. So I thought you were going to do the quiz or whatever. No, is it? Wasn't that the way it was done? I don't know. Oh, okay. Okay, so I didn't get enough time to say what maybe I should go back to the sharing mode now. Let me try to do that. Yeah, see, it's all this modeling of human dilemmas and forming principled arguments, listening comprehension and rebuttal. So in this case, you need to be able to understand what the other person said and figure out what that person said might not be complete or it's only partial facts and so on. So you need to be able to go and look at all sorts of knowledge sources. So you need to figure out what are all the trustworthy knowledge sources versus random stuff that's out there. Just because something is there out in the web, that doesn't mean it's true, right? And there'll be also, like I said at one point, inconsistencies. One place might say, these symptoms mean it's cancer. Another place might say, oh, those symptoms don't mean cancer. So even for the system to know what sources to give credibility to and what sources to ignore, this is like somebody might say, oh, New York Times is more reliable than, I don't know, the Hindu or whatever, right? Or between Hindu and Indian Express, which is more trustworthy. Things like that. Facebook posts may not be as trustworthy as something that's in a textbook, right? So there are things like that that you need to worry about. And also this data-driven speech writing and delivery, pushing frontiers of AI so we can build well-informed arguments and make better decisions. You need to be able to communicate things in an effective way and so on. So some of these APIs have to do with doing all these things that relate to what are all the various things that you need to be able to do in order to behave like a human being that's engaged in a speech and debate competition. Okay? And there is more of it here on this slide, by the way. 400 million articles, argument mining, they call it, debate construction, argument knowledge base, rebuttal. So this is claim detection, evidence detection. So you want to first figure out, see, the system can be told, you shall say, if let's say that the debate topic is Chandri is a good guy. The system could be told to support that or to take the counter position. Okay. And then it has to now come up with reasons as to why he is a good guy or not a good guy. And what arguments are you going to put forth to prove that he is good or not good? Where do you go find information? Maybe, you know, he posted something where he said something really bad about Mohan. And does that mean that he is really a bad guy? Maybe what he is saying is the truth about Mohan. So this all gets very complicated, right? So claim detection, evidence to go and back up that claim, and also the stance detection. Can you even tell? This is, by the way, the stuff that some of you might have heard about or worked on, which is, can you tell from a tweet whether somebody is saying something positive or negative or doesn't care? Even in reviews of books, for instance, can you tell whether, you know, my wife has published a couple of books, right? Is this critique saying something good about this book, or it's saying something bad, or it's saying both good and bad? So sentiment detection is what this is called, right? So in a similar way, you have to also detect whether somebody stands for certain principles or not, and things like that. So anyway.
Yeah, the next one is why AI. Yeah, the next question is why.
Robin, you want to choose? It's easier for me to.
Yeah, you can choose, sir.
Okay, yeah.
Robin, you can read out the questions.
Yeah, that is why AI 2.0 is uncertain.
Robin is missing. Okay, let me. Okay, why AI 2.0 is uncertainty? I'm not even understanding what that question is saying.
Then go to the other one. Which AI algorithm is helpful for healthcare data analytics?
I didn't say that. I just said, there was initially AI 1.0, and that's the kind of thing that, Raj Reddy and various people worked on, which had to do with more of the DARPA wave 1 kind of technology, where it was domain specific and handcrafted knowledge and such. AI 2.0 is more like this current thing, which is all this more machine learning based, and these 3 guys who got the Turing Award most recently, 2018, that was for that kind of work. And that's the one where it's based on statistical reasoning rather than very involved codifying of knowledge about different domains, and thereby, like in the case of originally speech understanding, syntax, semantics, and all that being taken into account, and or in production systems and so on, expert systems, they codified the decision rules kind of things, right? But with this more statistical based approach, you are not able to explain the logic behind why a certain conclusion was arrived at. You can only say, oh, this black box came up with this conclusion, but you are not able to sort of go backwards and say, until this point in its analysis, it thought this was a cat, but then it saw this feature, and that's when it said, no, it's not a cat. So it cannot, it's like when you go to a doctor and the doctor says, hey, we think you are on the verge of contracting diabetes, they'll be able to tell you a few reasons behind why they came to that conclusion. So it's that sort of thing that these algorithms are not able to do at this point. There's lots of people working on this so-called explainability aspect of these machine learning models. But I'm still not, can the person who asked the question speak and ask what was meant by this is uncertainty? Okay, while that person is
Yeah, we can go with the other.
yeah,
Which
theme on
algorithm
AI
is-
snake oil, sir. I don't even understand again this question. The point of that paper by the presentation by Arvind Narayanan of Princeton University was that whenever some topic becomes popular, people want to latch on to that topic and act like what they've got is leveraging this currently popular technology, and they think as a result their product will sell better or they will be employed to develop something and such. So this is more marketing gimmicks than reality. In fact, even this morning's presentation, Balraman talked about how, they thought machine learning was needed in a certain domain, and then one of their students went and showed that some age-old way of doing things was perfectly fine for a particular domain. So it's like, you have a hammer and you are looking for a nail. And and by the way, this is similar to a lot of people thinking, anywhere and everywhere they should use blockchain. There are certain use cases for which blockchains are appropriate, but there are other use cases where traditional database technology and transaction processing technology is the appropriate thing. It's that sort of thing that applies even in this space. Certain performance requirements or inability of your people to develop these more handcrafted kind of schemes of the old days might be the reason you don't have a choice. But don't get carried away thinking, just claiming that you are using AI is going to by itself make your solution be thought of in a better light than somebody else's solution. And that's where I gave you as an example, this silly thing where somebody said, oh, while the person is being interviewed, just analyzing the facial expression of the person can let this algorithm predict whether this person will be a good employee, a long-term employee, a loyal employee or not, and things like that. There's in many ways like our astrologer type people telling us, or Kili Josiam and all these nonsense things, right? Or people say they can look at your palm and predict stuff, or in the Turkish coffee, they say after you've drunk the coffee, the pattern that you see at the bottom of the cup, because there's some solid stuff that's a remnant, that can also say something about your future life and things like that. So, right. Okay, so what's the next one? Which AI algorithms are helpful for healthcare data analytics? I mean, there is no such thing as a particular algorithm as such. It's a matter of you have to go look into the particular aspects that you are trying to understand. And so I myself, I'm not an expert on all these different things that are out there, traditional, statistical approaches. And so I'm not able to comment specifically on, is this method better than that method and things like that, for what kind of use cases. I'm more an observer of what all has happened over the years, and I'm trying to caution people. I'm not trying to give particular solutions for anything. Okay. Why? Okay. I think, yeah. Okay.
What is the limitation for narrow AI for a general AI?
Or do you want me to just show I can show that Word file. Oh, but then you have all this polling thing that won't happen. But it looks like Robin is incommunicado.
But
Oh,
before
yes.
that, sir, we'll go to the Slido quiz, then we'll come back with they ask any questions.
Okay. Oh, yeah, I did. Yeah, thank you.
Shall we go for a Slido?
Okay. Wasn't he listening to us?
He was listening.
Oh. Oh,
Okay, participants,
yeah, I noticed.
please register for Slido quiz. That link is pasted in the chat box. So I will give a minute.
Pals PMO is talking, but I'm not hearing anything.
No, I can able to hear you.
Okay, I don't know why I didn't hear you before.
Okay, fine. That please register for the Slido quiz. So I'm going to share my screen. I will give a minute. I think you can able to see my screen. Are you able to view my screen?
Yes, I'm saying the QR code.
Slido.
Yeah.
Okay, thank you.
Sure.
I request the participants, so please register your email ID and your name. So I will give a minute. I will start the quiz now. Let's see. Okay. 43, 47. We have around 130 plus participants. I request all the participants do register and attend the quiz. So this is the testing how much you have learned from this session. So I request all the participants to join the quiz. If we cross 100, then we'll start the quiz. For each questions, you have a 20 seconds. So it is objective type. So please attend. Okay, we have crossed 100 marks. No, not yet. 99. Anyway, okay, we'll start the quiz now. Yes, your first question. You have a 20-second. Which year did the phrase artificial intelligence emerge for the first time? You have 10 seconds. Let's see how many people have answered correct questions, correct answer. Okay, answer D. So majority. Okay, we'll move to the next. Which is the oldest major AI ML focused conference that is still held every year? Okay, you have 14 seconds. So fastest finger first. So okay. Okay, let's see the answer. Answer A is right. Okay, majority. The next question, according to DARPA, which attribute AI wave 1 approach better in terms of national intelligence scale compared to wave 2 approach? You have 10, 9 seconds, 8. Okay, let's see the answer. Okay, answer B, majority have answered. Okay. Fourth one, which of the following are good sources of information on AI? You have 1 second. Okay, let's see the answer. Answer E. We'll move to the next. What was the main point of those scientists? You have 15. Okay, let's see the answer. Answer E. Now we can see the leaderboard. How many have answered in the top? Okay, P. Arulmoli, that is 5 out of 5. Okay, good. So we'll move to the next 6th question. We'll see in the final who is the winner. Who is the only Indian computer scientist to have won the Turing Award? Okay, let's see the answer. Yes, answer C is the right majority. Okay. According to DARPA, which two attributes of AI wave 2 in terms of national intelligence scale are expected to improve in wave 3? Good. Okay, let's see the answer. Answer E. Okay, next one. Which is the best summary of what China wants to accomplish in AI? see. Okay, fine. Let's see. The answer is C. Majority have answered. The ninth one. According to IBM, which of the following areas of work need to be done improve AI performance? You have 5 options. Okay, let's see. Answer E, majority. The next final question. Which organization in Tamil Nadu focuses on AI applications? Okay, let's see. Okay, both. Okay, let's see the leaderboard now. Okay, congratulations. Arunmoli is the winner. So fastest finger. Mridula Prabha Abhitanik. Ernokshan Anto Hortless. Thank you. Thanks for the quiz participants. I will stop share my screen. You can take the photograph. I'll stop share my screen. Okay.
Okay, congratulations to all the winners. I'm very impressed. Arul Murray was doing so well.
Participants, if you have any questions, you can ask. Thank you, sir. Arulmoli said that. Thank you, sir.
Oh, welcome. Where is she? Which college? Maybe you should in the future for each of these people also mention their college. That'll be good for the college too.
1 second, I will if I'll unmute her, you can. Dr. Arulmoli, you can unmute yourself.
Anyway, Robin, the suggestion for the future is show the institution also, in addition to the, yeah.
She is from KCG. She is from KCG College of Technology.
And where is it?
It is in Chennai.
The leaderboard, Robin,
Yeah.
all those winners, they can actually unmute their camera, they can show a picture. You can take a screenshot of them, and put it out as the end of the whole thing,
Yep.
It'd be a good recognition for them.
Yeah.
Okay. But nobody is switched on.
Well,
Dr. Arulmoli.
We always learn. We learn every session. New technology and new things. Yeah. Good.
All right. Oh, that's maybe.
These are the leaderboards.
Oh, I see.
Okay.
Good.
You can turn off your camera. We are not the leader.
Oh, okay.
You can take a screenshot. Okay. Who else? Who are the winners?
Dr. Arulmoli, you can switch on your video. Only three participants, 3 winners have.
Okay, let me, since they can't see me. Congratulations. So maybe each one of you, which college you are from and what town it is in. Go ahead, Mary. Virgil.
1 second, I will mind.
Oh, I see. I thought once the video was on, the audio also.
Mary, you can unmute yourself.
Good evening. Good evening. Good evening,
Yes.
sir. Sir, I'm from Loyola Ecom College of Engineering and Technology. I'm working as an assistant professor in the Department of Computer Science and Engineering.
He's from Loyola College.
But it's the Chennai one, or where is it located?
Sorry?
Is your college in Chennai?
Yes, sir. It is in Chennai, in Nungambakam, inside Loyola campus.
I did PUC in Loyola College pre-university course, 1971 to 72.
Okay, sir. Nice to hear.
When women were not even allowed as students, it was a male-only college. All right, good. Next person.
That Amir, you can unmute.
Yes, sir. I'm from Ali Muhammad Ali College of Engineering. It was located in Navali, Chennai. And I'm a
Where?
second year student.
Located where?
Avadi.
Chennai.
Chennai.
Oh, Avadi, Chennai. Okay, got it. Thank you.
And I'm a second year student, sir.
Great. Under bachelor's degree.
Yes, sir.
Okay,
Then Mohammed.
congratulations.
Next person,
Mohammed.
you can unmute.
Oh, looks like they are both next.
Hello,
to each
sir.
other.
Yeah.
Hello, sir. I'm Mohammed Ajmal. I'm from Chennai, Avadi, from Ali Muhammad Saleh College of Engineering. I'm second year.
Very good.
Second year. So both of you are in the same college?
Yes, sir.
Okay, congratulations. That's good. Thank you.
Thank you,
Oh,
sir.
Arulmari, she's there now.
Go ahead. Anurag.
Dr. Arulmoli, you can unmute. I have given access. She has some connection issue or something.
Oh, she's frozen. Ah, now she's moving.
Okay.
Arulmari,
No,
you
she
can
said-
unmute.
No, she said she is not having that camera facility. I don't have camera, so she has mentioned.
No, she's visible, but she has to just unmute.
Is it? Oh.
Yeah. Her video is coming through.
Yeah. Ma'am, you can unmute now.
Maybe she's not hearing us. I'm not sure what's going on. Oh,
No, she has some audio problem or something.
oh, okay.
Audio problem in another meeting.
Oh, okay. Anyway, Arulmari, congratulations. See, I can't even tell whether she's hearing or not. That's the problem. Okay, maybe
We can go for wrapping up. We'll wrap up, David.
Yes, sir.
Yeah.
Okay.
Yeah, I think, thank you, Mohan, for coming over and, he has actually gathered literature over the last 65 years, right from first year of his birth, got so much of information. It's not one of those typical past lecture, we do a deep dive technically into one area, but rather what he's done is he has actually compiled information, across different, institutions like ACM, IEEE, and different countries, different nations. He travels across different nations. He started from Tamil Nadu, in fact. He just referred to a conference that's going on about 4 miles away and shared what's going on and went all the way to US Congress talking about the enactment of AI, and then he also mentioned about what's going on in India. I think I think we shared the PowerPoint presentation or whatever, what he's going to talk today. We shared with you yesterday. I'm sure, it's not just 24 hours is not enough to go through all the material, but the idea is future, He's talked about AI, past, present, and future. Whatever he has shared with you today is just an eye-opener, ear-opener because AI is, emerging so vast. with all sorts of things going on, I think Mohan touched upon almost everything related to AI. But it is for us to do a deep dive and probably requesting for any session in any one area. In fact, he's going to be here for some time. He has also agreed to be connected. He shared a lot of his contacts. You can use Instagram or you can use Twitter. You can use Facebook to connect with him, and he's available is practically 24/7. The only time he doesn't look at the computer or mobile is when he's on the flight when there's no network available, or he passing through security in the airport when they don't allow him to do this. Other time he's always on the network and he connects with everybody and he responds to everybody's request. So again, we are going to have a session on survey of cloud database tomorrow. The other thing I want to tell you is from IBM, and we are already working with IBM through the IBM Skills Academy. We can do a deep dive on yesterday's session, cybersecurity, on artificial intelligence. They're going to have a deep dive T3, Teach the Trainer program, where they're going to have 60 hours of learning on say 7 or 8 areas. We'll reach out to you sometime in January to register for those programs. They will get certificates, and we are working with IBM on the modalities of administering these courses so that you can benefit from IBM. Okay, so stay tuned. Again, we will have a Mohan session tomorrow. Thank you for your questions. Thank you to Mohan for comparing such a vast amount of literature for us to keep learning about artificial intelligence. And by the way, he touched about artificial general intelligence. One more IIT alumnus and our classmates, Prabhakar Balakrishnan, he written a book as Purpose, which is on artificial general intelligence. Yeah, AGI. He actually wanted to share on AGI with PAL students. We'll schedule a session. He is in Virudhunagar.
Thank you so much, Chandri and RKR, I got it right, for this, for all the help that they gave me in terms of getting this presentation scheduled and also physically bringing me over here, RKR, and he's going to take me back too now. So I really appreciated also all of you joining on a Friday afternoon. I don't know how many people are going to show up for the session tomorrow, which will be in the morning on a Saturday. So that will be on cloud database system. So good luck with whatever you are into, whether you are studying or doing research or combination. And one of you said, Mary, I think you are also a faculty member already, right? Are you doing a PhD now, or what are you doing? Or just a faculty?
Sir, I've submitted my thesis.
Ah, congratulations. Wonderful.
Thank you, sir.
And you did it in the same college?
I did it in College of Engineering, Guinea, sir.
Oh, I see. Okay, wonderful. All the best for the defense. So the defense is over, or defense will be in the future?
It is yet to come, sir.
Okay. All right. All the best.
Thank you, sir.
Thank you so much.
Thank you, Dr. Mohan.
Thank you, Robin, also for your help in putting together the whole thing, and also to the staff here at the IIT Madras Alumni Industry Interaction Center. Yeah, this is the first time I've come here. So the club used to be somewhere else before. So I appreciate all the help that they provided also. Sorry for the screw up in the middle where my computer went to sleep, because the connections are so flaky that I didn't realize it went into power saving mode. So sorry about that.
Okay, thank you.
Yeah,
thank you.
Thank you. Bye-bye.
I request the participants, the feedback link is posted in the chat box. Please submit your feedback. And tomorrow you have the session in the morning. So please join around 10:30 the session. So 15 minutes before you join. Okay. Thank you. Thanks for the participants. So please submit your feedback. Thank you.